This is pretty much a challenge problem, an outside the box problem for figuring out the atomic mass. In this problem, actually, they've given you the average atomic mass or the atomic mass number for rubidium. And so they're trying to figure out what is the actual mass for rubidium-87. So we know it's got to be somewhere around 87, but it wants the number. So this is the information that they give me. And so we're going to kind of start with the formula that we know that atomic mass, or the average, is equal to the percent abundance, so the percent of the isotope times its mass. So we're going to just say for mass of isotope 1, plus the percent abundance and the mass of the isotope 2, and so on. So if you have several isotopes, you would just add them together. So if we take a look at what we know, always start with the formulas you know. So we're plugging in what we know in this problem. So the atomic mass that they tell me for rubidium is 85.4678 AMU. Well, they don't give me the percent, but I know this thing that if there's only two things, then I know that if I have 80% of one, I have to have 20% of the other, so they always have to add up to 100. So if we deal with this by moving the decimal over, let's make them add up to 1. So I'm just going to make this first percentage for rubidium, the RB85, I'm going to say that that percentage is 1 minus x. And I know its mass. It gives it to me right here. It's 84.9117. And then the next one, if this is 1 minus x, then I'm going to make the rubidium 87, I'm going to make that x. But the problem is, oh, I have another variable now, because I don't know rubidium 87's actual mass. Somewhere close to 87. I could plug it in and probably go with it, but that's not what we're going to do here. It wants the number, so we need to make sure we do it. So I'm just going to put down rubidium 87 as my variable. So now I have two variables. But what's nice is look what they did. They told me that rubidium 85 to rubidium 87 has a ratio of 2.591. If we stand back and look and you're like, well, then how do I go from there? But look, this is rubidium 85. This is rubidium 87, and look what we called it, x and 1 minus x. So let's plug that in. Let's just see if this works. So rubidium 85, I'm going to plug in 1 minus x for that. And for rubidium 87, I'm going to plug in x, and that's going to equal to 2.591. So now let's see if we can solve for x. And now it's just a little bit of algebra. So I'm going to move x up, and so I'm going to get 2.591x equals 1 minus x. I'm going to combine terms, so I'm going to move x to the other side. So I'm going to get 2.591x plus x equals 1, or 3.591x equals 1. And I want to solve for x, so I'm going to divide both sides by 3.591. And so then I determine that x is equal to 0.278. Which makes it very nice, because then now all I have to do is plug that in there, and then start doing some algebra. And I think I will be able to find the rubidium value. So 1 minus x, so if I look at 1 minus x, so 1 minus x, okay, if x is equal to 0.278, so 1 minus x we do some math in there, is equal to 0.722. So now I'm just going to plug this in to our original values. So up here, and I'll transfer it down here in just a minute, but this is going to be 0.722, and this is going to be 0.278. So now I'm just ready to do some algebra. So let's rewrite this. 85.4678 equals to 0.722 times the mass of rubidium-85, which was 84.9117, plus 0.278 times rubidium-87, which I don't know. So I'm just going to solve for that. So again, if we just work it through, we do the little bit of math here. We know that 0.722 times 0.84999117 is 61. I'm just kind of working it out. Doing that, plug it into my calculator, 61.306, I believe, plus 0.278 rubidium-87. Then I'm going to combine terms, and so I'm going to subtract the 61.306, so 85.4678 minus 61.306. I'm going to divide out the 0.278, and I'm going to end up with my rubidium-87 answer. So if I put all that into the calculator, it spits out, oh, let's see if that makes sense, 86.9129. That makes a lot of sense. Again, we want to kind of track our unit. That is an AMU. So that's close to rubidium-87, 86.9129. That would be the mass that it's looking for. So again, kind of just starting with your formulas, working through, figuring out what you know.